But now the hardest thing to do is what I asked for was, what are the roots? Can you see the roots? Not exactly. We know they're between these whole numbers. There could be one between 0 and 1, and also one between 1 and 2. We could assume it's halfway between, but that's not precise. Okay, so we have another way to find that, and that's algebraically. So we're going to do that today, is find these roots algebraically by factoring. So when we can't see it, we'll be solving for these. And when you ever see the word or the instruction to solve, it's asking you to solve for the x-intercept, okay? You're algebraically solving for the x-intercept. And the most common way to solve for, I mentioned, is by factoring. Okay, so we're going to start by that method today, solve by factoring. And so what this is going to utilize is a thing called the zero product property. Because if we could write these as factors and we find how to make each factor equal to 0, then we are finding those x-intercepts, those zeros or roots. Alright, the first thing you're going to do in order to use this method is to replace your y or f of x if it's in function notation with 0. So sometimes that's already done for you. If that's not the case, then your next step will be to set everything equal to 0. That means move all your terms to one side. That would be your standard form. So after you get everything on one side, you're basically looking at standard form that's equal to 0 instead of y. Next step is to factor, and one way to always look for factoring is GCF, but you might also need to take care of a special case, like your difference of two squares, or your perfect square trinomial, or it might be one of those regular old trinomials. Whatever you need to do, you need to factor what you have. That way you take the standard form equation and you have it now in factored form. Alright, once you have it factored, you set it equal to 0, you got standard form factored. Now you're going to do split and solve. So you can take those factors, split them up, set each of them equal to 0, and then solve them separately. So you solve them each equal to 0. After you have those both solved, could be two equations, the last thing you do is take your answer and write them as solutions, as x-intercepts. So each of those root values will be its own x-intercept, the number, the root value, and then comma 0. All right, we're going to practice on the example we just graphed above where we couldn't see exactly where they were. So now we're going to verify by solving these algebraically by factoring. So if you remember up above, we have the standard form equation 4x squared minus 8x plus 3. Again, this is in standard form. In order to solve by factoring, we're going to have to write this in factored form. So we're going to take this equation and write it in factored form. So two binomials that multiply to make the original there. Well, it's kind of easy because we have a nice prime number at the end, positive 3. There's only a couple ways to make 4x squared. That's going to be 2x times 2x. But there's only one way to get positive 3, and that's going to be 3 times 1. We're going to make both of them negative because we have minus 8x in the middle. So if I make these both negative, I'm going to check I factored it correctly though. Let's see, negative 3 times 2 is negative 6, and then we'll have another negative 2, to make negative 8 in the middle. So there's our factored form. Now, we can't see the opposites here. We know it's not crossing through positive 3. We know it's not crossing through positive 1. We know it's some sort of fraction. So instead, we're going to take each of these and set them equal to 0 and solve. Let me move this up a little bit. We have it factored, and now we're going to do split and solve. So 1 comes out, so 2x minus 3 equals 0. And we'll do the other one as well. 2x minus 1 equals 0. So these are two-step equations we're solving. On this one, we're going to add 3 and then divide by 2. So that answer would be 3/2, which is also 1.5. On the other equation, we add 1, divide by 2, we get 1/2, or 0.5. Now we go up and verify those are the actual values in our graph. Let me zoom up there real quick. We got x value is 0.5 right there, and the other one was at 1.5. Okay, so we can see it precisely now algebraically by solving through factoring. So don't forget, when you solve quadratics, when you solve a quadratic equation, you're finding the x-intercepts. You're finding the x values that make it equal 0. So those x-intercepts in our problem are, our x-intercepts are roots, same thing. We have one over here. The smaller one was 1/2 and 0. And the other root was 3/2, comma 0. Alright, these are the 3 practice problems that we were supposed to do. The first one was nice because it's already in standard form and it's already equal to 0. So what we have to do next is just factor it. So let's go ahead and do that. Let's do that up here. So if I want to factor that, it's a nice one because it's an x squared, so we can use the pattern what multiplies to the last term, negative 14, and then what adds up to the middle, negative 5. That would be our positive 2 and negative 7. That would make us negative 14 in the end and then negative 5 in the middle. All right. After we factor it, we're now going to split each factor and set them equal to 0. So we'll have x plus 2 equals 0, x minus 7 equals 0. One-step equation to solve. Subtract 2 to get x equals negative 2 on that one. Over here, we're going to add 7 to get positive 7 for that answer. That makes sense because we saw in factored form that these are the opposites come out to be our root values. So opposite negative 7 is positive 7. Opposite negative 2 is positive 2. And that makes sense that they're called zeros because those opposites makes the whole thing equal 0. Last thing we have to do now is write those as x-intercepts. So this one would be negative 2, 0, and then our last one would be 7, 0 for those two roots. On the next one, we had to do GCF factoring here. So can't factor it as a trinomial because it's not. But we do have a GCF there. It's this one up here. So a GCF of 3x, I believe. They both have x, and 3 is the biggest number. It goes into both of them. So we're going to factor out 3x. So 3x comes out, leaving us with x minus 2 on the inside. Double check that. If I distribute, I get back to the original equation. Alright, now we have our factors. Now we are going to split and solve. Split the factors, so that becomes 3x equals 0. That's going to be x minus 2 equals 0. Now you notice it's not as easy as opposites for one of these because this is not a binomial. So we have to actually solve this when x is not a regular x like this one is. We have 3x here. We're going to separate and solve. We get 0 for that one. Divide by 3. On this one over here, we're going to add 2, and we'll get the opposite number. So x equals positive 2. So there's our roots. We have a root at 0, 0, and at 2, 0. In our last example here, it's not equal to 0. So we're going to have to move over the 18 and then factor. So we're going to move things by doing the opposite. So minus 18 from both sides. That would give us the trinomial x squared plus 3x and then minus 18. What's left over there is 0. Once you move everything over, it will be equal to 0. And now we are going to factor. We have one of our regular x squares, so it's going to be easy to factor. X times x for x squared. And we're looking at what multiplies to make negative 18, and then adds a positive 3 in the middle. So that should be positive 6, so plus 6, and then negative 3. Still equal to 0. After we factor, we split and solve. X plus 6 equals 0. X minus 3 equals 0. So over here we subtract 6 to get the opposites, negative 6. Add 3 to get the opposites, positive 3. So there are our x values of the roots. So let's make those x-intercepts. So this one would be at negative 6, 0, and the other one will be at 3, 0. All right, may the math be with you.